Namaste. Solution, the new video. The chapter is full of problems, and that is also having very low level to high application level. It's a throughout that chapter is dealing with so many numerical side. Okay, colligative property, it's a new idea. It's a continuation of first chapter, basic concepts of chemistry. That last area of that chapter is dealing with how to express the concentration of solution. The same thing repeating here also. Knowingly, I avoided the questions of concentration methods. Strictly the remaining part of the solution, okay, I placed as the main discussion question. Moving to the first question. Two liquids A and B have P0A, P0B, that means pure vapor pressure, in the ratio 1:3, and the ratio of their number of moles of A and B in the liquid phase is 1:3. Then mole fraction of A in the vapor phase, equilibrium with the solution at the same temperature, is equal to. The very first question itself is having some numerical steps. See, vapor phase mole fraction, that is actually obtained from Dalton's law of partial pressure. Okay, Xi, I think the question A, vapor phase, Xi is equal to mole fraction. The real formula, partial pressure of A is equal to total pressure into mole fraction in vapor phase. So mole fraction in vapor phase is equal to partial pressure of A divided by total pressure. So that idea is coming from Dalton's law of partial pressure. So for answering that equation or that question, you need two data. One is the partial pressure of the component A and the total pressure. According to Raoult's law, I think you know the statement of Raoult's law, total pressure P is equal to PA plus PB. This is not Raoult's law, this is Dalton's law. According to Raoult's law, PA is equal to P0A into XA and PB is equal to P0B into XB. So I am substituting P0A. They are giving only the ratio. P0A, the ratio 1, mole fraction of A, not B, XA. Number of mole of A divided by total, that is also given as a ratio. Number of mole of A is 1, total is 4, so into 1/4 plus P0B, it is 3 into its number of mole is 3 and by 4. So what is it? 0.25 plus, okay, 9/4. What is 9/4? Again 0.25 plus 2.8, then 1/4, 2 high. So 2.5 is the total pressure and 0.25 is the value of PA. What idea? We need a PA and P0A. What is PA? Instead of PA, you are getting 0.25. Okay, and total pressure is 2.5. So answer here 0.25 divided by 2.5. Solve it and find the answer. Agree? What is it? 0.25. 1 by, you are getting an answer. Okay, the next question, number 2. Number 2, 0.01 molar aqueous solution of K4Fe, not K4, K3FeCN6 freezes at a temperature minus 0.0. Freezing point is negative, it's a normal thing, aqueous solution. 0.062 degrees C. One of the following is the apparent percentage of dissociation. It is. That means you are asked to find percentage of dissociation alpha. So in order to get the value of alpha, first of all you have to reach Van de Hoff factor I, and only after getting the answer of I you can calculate the last result. 0.01 molar aqueous solution of a compound given and freezing point is also given. There is a formula for finding I value. Every relation of colligative property is connected with I value. Every relation. See, delta TF is equal to I into KF into M is the formula, and obviously you can find I from here. I is equal to delta TF. The value of delta TF is 0.062 divided by KF value that is given in the question. Otherwise, you have to know 1.86 and 0.01. You just solve it and you are getting an answer I. Okay, and from that I you are getting percentage, because there is a formula for finding percentage alpha is equal to I minus 1 by n minus 1 into 100. Okay, you substitute the value of I minus 1 divided by, okay, after solving this side you are getting the value of I, substitute here minus 1 divided by n. The compound is K3FeCN6. When that compound dissociate, you are getting 4 particles and that is value of n, so n minus 1 into 100. Okay, that is answer. Work out it and tell me the answer in the group. So 2 steps further. First you are assessing the value of I, and using the value of I you are getting percentage of alpha. Agree? Question number 3. The correct decreasing order of the boiling point of solutions, they are giving 1, 2, 3, 4. 0.1 molal glucose, 0.01 molal Na3PO4, 0.005 molal K4FeCN6 and 0.3 molal sucrose. Everything is molality, small m, molal. What is the meaning of 1 molal, you know? 1 molal means 1 mole in 1 liter, sorry, 1000 gram. 1 mole in 1 liter is 1 molar, capital M. Since it is molarity, 1 mole in 1000 gram, 1 kilogram is 1 molal. So 2 molal means 2 mole in 1000 gram. 3 molal means 3 mole in 1000. So 0.1 molal glucose means 0.1 mole of glucose in 1000 gram. I am taking all the options in 1000 gram. So you can take the molarity value as the number of mole. Okay, that is the logic here. Molarity value as the number of mole. So let us analyze the number of moles of each and every compound. First one point is 0.1 molar glucose. 0.1 molar glucose means 0.1 mole glucose. 0.1 is the number. Number 2, it is giving 0.01 molar means mole Na3PO4. Here there is a problem. Na3PO4 when dissociate you are getting 4 particles. So 4 into 0.01 means 0.04 mole of particles are present in number 2. Number 3, 0.05 molar. 0.05 molar means mole. The compound is K4FeCN6. K4FeCN6 means this dissociate to form 5 particles. So 5 into 0.05 means you are getting 0.25 mole. A point is 0.05 already there into 5. 0.25 mole of the particles present in the third one, and the last one 0.3 molar glucose, sucrose. Fourth one 0.3 molar means 0.3 mole of sucrose. Sucrose and glucose cannot dissociate, they are non-electrolyte. So these are the number of particles 0.3, 0.25, 0.04 and 0.1. Okay, since the question is correct decreasing order of the boiling point, what is the property, colligative property connected to boiling point? Elevation boiling point. Okay, higher the value of the number of particles, higher will be the colligative property, means higher will be the boiling point. So the maximum boiling point stands for 4, then 3, then to 1 and finally goes to 2. Okay, such an option is there. You find it and submit as assignment. Number 4. Empirical formula of a non-electrolyte is CH2. Empirical formula, you know the meaning. 1 liter of a solution containing 6 gram of that compound has same osmotic pressure as 0.05 molar glucose. 0.05 molar glucose, okay, there is a particular osmotic pressure. Same osmotic pressure is possible for a non-electrolyte. So both are non-electrolyte, so there is no problem regarding I. So both of them have same number of particles. What is the meaning 0.05 molar? 0.05 mole in 1 liter. So here also 0.05 mole of the unknown compound, 0.05 mole of unknown compound present in 1 liter. Okay, so number of mole of the unknown compound is given. So obviously you can find the molar mass. Okay, 0.05 mole, 0.05 mole, 0.05 is equal to weight divided by molecular mass. Agree? You are asked to find the empirical formula, that we can find, no problem. 1 liter of solution contain 6 gram of the compound. So compound weight is 6 gram. This is 6 gram. So I am writing 6 here. So what is MB? MB is equal to 6 by 0.05. Agree? So that you are getting the molecular mass of the compound. Okay. The problem is not over. After getting the molecular mass, you can find the molecular formulae. Here it is not molecular formulae. Yeah, molecular formula, empirical formula is given. You are asked to find molecular formula, means there is one more connection. Okay, see, the connection is, there is a relationship between empirical formula and molecular formula. I think you know. Molecular formula is equal to empirical formula times N, means CH2O times N. Okay, that N you have to find. And for measuring the value of N, another formula is the molecular mass divided by empirical formula mass. That molecular mass you are getting from here. That molecular mass, what is 6 divided by 0.05? What is 6 by 5? What is 6 by 5? 6 by 5 into 10 raised to, minus 2 is the square. 6 by 5 is 1.2. So 120 is the molecular mass. So 120 divided by empirical formula, the question provide empirical formula CH2O. CH2O means C12, H2, 2 hydrogen, and O 16 means 30. So divided by 30. So 4 is the value of N. So times 4 means C4H8O4 will be the correct molecular formula of the compound. Agree? So it's a mixed question. Actually, empirical formula, molecular formula, that is alone asked as a question, but they are giving it in a background of solution. So option is there, you find it and tell me the option. Question number 5. At 25 degrees centigrade, the highest osmotic pressure. So direct question, 0.1 molar is the concentration of every option. So no problem regarding concentration. So you look at the formula only. Urea non-electrolyte, glucose non-electrolyte, KCl dissociates into 2 particles and calcium chloride dissociates into 3 particles. So higher the value of the number of particles, higher will be the reactive property and higher will be the osmotic pressure here. So tell me the answer, as an assignment. Number of particles is the basic backbone. Next one. 5% solution of cane sugar, 342, you know, the molecular mass is isotonic with the 2.5% of unknown compound X. What is the molecular weight of X? See, isotonic means having the same osmotic pressure or having the same number of particles. So I am proposing that number of moles of cane sugar is equal to number of mole of X. Number of mole of cane sugar means weight by molar mass. 5% you can take it as 5 gram. So 5 by 342 is equal to 2.5 by mx. We don't know. Number of mole is obtained by weight by molar mass. Weight to percentage you take it as weight. So when we are cancelling, it become 2. So mx equal to, what is answer? 342 divided by 2. Answer is there. Clear? So that is over. Next one. You find the answer and tell me. I am not solving each and every step of the question. Next one, 7th question. Increase in the boiling point of a solution containing 0.6 grams of urea in 200 grams of water is 0.5. What is the molar elevation constant? Compound is urea, so there is no need of I. And it is directly asked molar elevation constant KB. What is the formula for finding delta TB? You know, delta TB is equal to KB into WB into 1000 divided by MB into WA. I am rewriting KB is equal to delta TB into MB into WA divided by WB into 1000. I am substituting delta TB elevation boiling point. How much is the boiling point is increased? 0.5 into MB molecular mass of urea, I think you know, 60 into WA weight of the solvent, that is 200 gram, divided by WB weight of the solute, how much grams of urea? 0.6. So you can easily solve it into 1000. Solve and find the answer. So 5.5 you can easily cancel. 0 you can cancel. You are getting an answer. I think it is 1. You verified and tell me the answer. Okay. Question number 8. A mixture of liquid A and B shows negative deviation from Raoult's law. Negative deviation means theoretical vapor pressure, observed vapor pressure. When we are comparing, observed vapor pressure is less than that of theoretical vapor pressure. And that is because after the formation of solution, molecular interaction becomes stronger. Okay. Enthalpy mixing negative, volume mixing negative, everything is negative. So let us analyze. Yeah, AB interaction is stronger than A and BB interaction. Yeah, that is why vapor pressure decreases. AB interaction is weaker than A and no. If it is weaker AB, positive deviation happens. Delta V mixing positive, delta S mixing positive. No, it is positive deviation. Delta V mixing equal to 0. It's wrong. So only one answer. First one. Azeotropic mixture, question number 9, azeotropic mixture of nitric acid water. That is directly given in NCERT. What is the meaning of azeotrope? I told you once. Okay, constant boiling mixture, and it is 68% HNO3 by mass. Okay, you are learning 2 types of azeotropes, low boiling azeotrope and high boiling azeotrope. This is high boiling azeotrope. Low boiling azeotrope is 95% ethanol and 5% water. That is shown by solutions with a positive deviation, and this is shown by solutions with a negative deviation. Okay, you know that. Question number 10. One of the following concentration affected by temperature. Since there is temperature connected to volume, if there is a volume term in the expression, definitely that is subjected to the change in value when we are changing temperature. First one is molarity. It is answer. Molarity, there is no volume. Mole fraction, there is no volume. Weight fraction, there is no volume. Okay, only molarity as per the given option. Molarity contain volume term. Since volume is sensitive towards temperature, it will change. The value of molarity will change with the temperature. Question number 11. Volume of 10 normal and 4 normal HCl solutions required to make 1 liter 7 normal HCl. That means you are mixing 2 solutions of HCl. One is having normality 10, other is having normality 4. Total volume is 1 liter, but the resultant normality should be 7. So respectively, you have to find how much is the volume of the individual solutions of HCl. You see? Okay, they are asking in a different way, that's all. We have discussed in the normal class also the same type of question. There is a formula, resultant normality into resultant volume is equal to. Resultant normality into resultant volume is equal to N1 V1 plus N2 V2. Otherwise, resultant normality is equal to by volume, total volume. Anyway, resultant normality they are giving at 7. So 7 into 1 is equal to 1 is 1 liter. I am giving in liter because all the answers are in liter. N1 first normality, that is 10 into, we don't know the volume first, so I am taking it as x plus N2 4 into 1 minus x. Why? Because total volume is 1 liter. Out of the 1 liter, x is the contribution from first part 10 normal, and 1 minus x, that is the volume of the next part having normality 4. Just solve it and find. What is it? 10x plus 4 minus 4x. Okay, 7 equal to. So this is 6x. So 6x equal to, okay, 3. Therefore, x equal to 3 by 6, 0.5 liter. If x is 0.5, 1 minus x is also 0.5. So 0.5 liter of 10 normal HCl and 0.5 liter of 4 normal HCl. That will be the right answer. Okay, option is the find it. Question number 12. Henry's law constant is minimum for the dissolution of. Henry's law constant minimum means highly soluble. Okay, Henry's law constant high means I will explain Henry's law. Okay, see, amount of gas dissolved in a particular volume of solvent at a constant temperature. That amount I am giving it as mole fraction. Since this chapter is mainly dealing with the mole fraction and pressure, you know Raoult's law. So I am expressing the amount of the gas in mole fraction. So mole fraction of a gas dissolved in a particular volume of solvent, okay, at a particular temperature is directly proportional to the partial pressure of the gas acting on the surface. Not to the total pressure, partial pressure. So x equal to K into P, where K is the proportionality constant. Higher the value of K, more will be the solubility. It is not Henry's law constant. From here I am rewriting what is P equal to. P is equal to 1 by k into x. This 1 by k is called as Henry's law constant kh. Okay. So higher the value of k, more will be the solubility. That was my argument. So lesser the value of kh, more will be the solubility. So here the question asked, Henry's law constant is minimum. Okay, Henry's law constant minimum means solubility is more. Clear? Here there are two gases given, one is N2 and other is O2. Four options were there, but first option O2, second option is also, but they are giving different temperature. When we are comparing nitrogen and oxygen, which is having more solubility, oxygen is more soluble than nitrogen, that you are dealing in inorganic chemistry. So your answer lies in oxygen, because Henry's law constant minimum means highest solubility. So answer goes to oxygen, but in oxygen there are two versions. One is at 293 Kelvin and other is at 303 Kelvin. You know what is the connection between solubility of a gas with the temperature? Lesser the value of the temperature, more will be the solubility. So answer option oxygen with the lesser temperature. Okay, find and tell me the answer. Question number 13. Mass percentage W by W, that is a way of representation, is the mass of the solute in 100 gram of the mixture. 100 gram of the solution. Answer is the 10 gram glucose dissolved in 90 gram of water. That means total 100 gram. 10 gram glucose, 90 gram water means total mixture 100. The percentage of the glucose is 10 W by W. 10 percentage W by W. Hey, you imagine 10 gram of glucose present in total 100 gram of the mixture. That is the meaning of 10% W by W. Agree? Answer is there. Find it. Mole fraction of benzene in 30% W by W solution in carbon tetrachloride. I will give the steps and you find, you solve it. 30% W by W, the meaning 30 grams of benzene. Okay, 30 gram benzene and 70 gram CCl4. That is the meaning. 30% W by W solution of carbon benzene and carbon tetrachloride. Agree? So 30 gram benzene. What is benzene molecular weight? C6 H6. Okay, 6 into 12 plus 6 means 78 is the molecular mass. CCl4, carbon 12, Cl4 means Cl30, 1 chlorine 35.5, 2 chlorine 71, so 142 means 154. Agree? So these are the respective molecular masses. You are asked to find the mole fraction of benzene. So mole fraction of benzene. X benzene is equal to number of mole of benzene by number of mole of benzene plus number of mole of CCl4. Number of mole mean weight by molar mass. That means 30 divided by 78 divided by 30 divided by 78 plus 70 divided by 154. That is up to you. You have to solve it. Okay, simple division. And after calculating, tell me the answer. Okay, next one. Which of the following is or are true about, question number 16, is or are about true about molar elevation constant Kb. Molar elevation constant Kb, you know, it's a property of the solvent. First option, Kb denote the elevation boiling point for 1 molar solution. Yeah, you know, Kb, delta Tb is equal to Kb into m. Hey, imagine m equal to 1, then delta Tb equal to Kb. That is option 1. Kb denote the elevation boiling point for 1 molar solution. Kb equal to RTB square m1 divided by 1000 delta H vaporization. That is also correct. Number 3, Kb is a property of solvent, characteristic property of solvent. Kb depends on solvent. Why? Because the second option there is m1. m1 represents molecular mass of the solvent. I will give MA because in my class I am explaining solvent as A and solute as B, but your NCRT solvent 1, solute 2. Okay. So all of these are correct. That is answer. Question number 17, 0.31 gram. 0.31 gram of ethylene glycol. It is actually 0.31, not 31. 0.31 gram of ethylene glycol. That is a correction. You note it. 0.31 gram of ethylene glycol, C2H6O2 molecular formula is given. If it is not given also, you can find what is the molecular formula of glycerol. Mixed with the 400 gram of water. Kf for water is given and the solution freezes set. That means directly you are asked to find delta Tf. I will tell you. delta TF is equal to okay, KF into WB into 1000 divided by MB into WA. KF is 1.86 into okay, the weight of the solute 0.31 into 1000 divided by MB molecular mass C2 means 24, H6 30 plus O2 32. So 10, 12, okay, 62 is the molecular weight. You can cancel easily, okay. 62 into WA, what is the weight of solvent? 400. Solve it. You are getting delta TF, but that is not the answer. You have to subtract it from 273.15 because answer 275.471, that means 0 degree is the freezing point of water. In Kelvin, its correct value is 273.15. Okay, so subtract the answer now obtained from 273.15. That will be the right answer. Agree? Solve it and find. Question number 18. Degree of dissociation alpha of a weak electrolyte AX BY is related to Van der Waals factor I by an expression. So many times it is asked as previous questions. The formula of the compound is AX BY. You know this dissociates as XA Y plus YB X minus. That is a way of dissociating this molecule. Agree? I is the Van der Waals factor. What is its expression? Alpha is the degree of dissociation. Alpha is the degree of dissociation means when we are taking 1 mole, alpha dissociate. That is the meaning. So I am initially taking 1 mole, no X and no A and no B. Suppose alpha dissociate, so remaining will be 1 minus alpha. As per this equation, 1 dissociate to form XA Y plus and YB X minus. So 2 dissociate to form 2X 2Y. So alpha dissociate to form 2, okay, alpha. Agree? And here not 2, X alpha. 1 dissociate to form X and Y. So 2 dissociate to form 2X 2Y. So alpha dissociate to form X alpha and Y alpha. Agree? Actually, these are the particles present after the dissociation, and the total number of the particle is equal to I. That is the logic. Total number of the particles at present in the mixture, that is actually I. I is equal to, tell me, 1 minus alpha, this one, plus X alpha plus Y alpha. Simply I am taking alpha outside, plus alpha I am taking outside. So I am writing X and Y initially minus 1. I equal to. So when I am taking X or 1 here, so alpha into X plus Y minus 1 equal to, okay, I minus 1. Okay, therefore what is alpha equal to? I minus 1 divided by X plus Y minus 1. Okay, that is the expression for alpha. Find it and tell me the answer. Okay, question number 18. Now moving to question number 19. Any problem regarding this question? How much particles present after the dissociation? That simply represent the value 5. Okay. 19. Density of 20% W by W aqueous solution of Ka is 1.2 gram per centimeter cube. Molarity. Directly I will give a formula and you just substitute, that's why. If percentage by weight is given and density is also given, molarity is given by the formula 10 dP divided by mb. That means 10 into the density value 1.2 into P percentage 20 divided by mb Ki means 39 and iodine 127. So 6 yes 166. Simply solve and find the answer. 10 dP divided by mb is the formula. Percentage by mass is given, density is also given. Then remember this formula, that is easy method, by heart it, that's all. Moving to the last question, question number 20. Vapor pressure of benzene and toluene 500 to 200 millimeter of mercury respectively at 343 Kelvin. Composition of the vapor phase Y, they are giving the symbol Y. Benzene is to toluene of a solution containing 2 mole of benzene and 3 mole of toluene. The solution is formed by mixing 2 mole of benzene and 3 mole of toluene. Their pure vapor pressures are given, and you are asked to find the composition means mole fraction in the vapor phase. That means similar to the first question. So I am going to find the total pressure, because total pressure, partial pressure, everything is required here. Okay. First question is dealing with the vapor pressure of only one component. Now it is dealing with both of them. Then only you can find the ratio. See, total pressure P is equal to P benzene plus P toluene, and this is equal to P0 benzene. I am giving the formula into X benzene plus P0 toluene into X toluene. P0 benzene, the value given 500 into mole fraction of benzene, number of mole of benzene 2 by total 5, plus P0 toluene, that is 200 into its number of mole 3 by 5. So cancelling 100, okay, 40 means 200, actually that is needed because PB is 200 plus 120. That means total pressure is 320. Agree? Total pressure is also required. Partial pressure is also required. Partial pressure of toluene, answer is 120. Partial pressure of benzene, that is 200. Total pressure is 320. As per Dalton's law, partial pressure of benzene is equal to total pressure into mole fraction of benzene in vapor phase. That mole fraction is given as the composition in the question. So, X benzene in vapor phase is equal to partial pressure of benzene by total pressure, means partial pressure of benzene 200 divided by total pressure 320. Find it. Similarly, X toluene vapor phase is equal to partial pressure of toluene by total pressure, means 120 divided by 320. Okay, you take it as the ratio. 200 ratio means X BV X TV is equal to 200 by 320 is to 120 divided by 320. 200 is to 120. What is it? 200 is to 120. You can cancel. 40. I am taking 40. So what will be when we are dividing with the 40? This become 5 is to 3. Option is there directly. Okay. So these are the questions from the chapter solution. Clear? So that's all for today. Most of the questions are numerical side, and I have given only the steps. Okay, substitutions only. Final step, that is up to you. You find it. Okay, verified with the answer key. If there is any problem regarding any question, you message me personally or in the group or through the YouTube. Okay, we can verify it. And if there is any correction, we can clarify. Okay, that's all. So tomorrow the next video will be connected to electrochemistry solution, then electrochemistry. Okay, so before that chapter you just study the theory, then only you can, because you have done the revisions so many times. Okay, once again you revise it and answer it. Okay, that's all for today. Namaste.